Hey guys. I'll move right on in. So, this is me. I am Johnny Christmas, he's not lying. I have done pretty much everything there is to do in the security space. I have a rule whenever I switch companies, I want to move into a role that's something I've never done before, so that I can come out of it with a way more well-rounded understanding of what the boots on the ground are doing in all these places. I started out as a systems engineer and then moved into network engineering because I was really drawn to that. I've been a hobbyist hacker for all of my life. I've gotten in plenty of trouble for it. I have a whole other talks on that. Moved into systems engineering, network engineering, yeah. So I was an information security engineer at a Fortune 500 company, Global 1000. That was amazing. I really got to cut my teeth in an amazing space when you're dealing with something that's at that level of an enterprise. That really gave me a great understanding of what's going on the business side as well as the IT side. From there, I was able to move into information consultancy and help other Fortune 500s, et cetera, deal with the security problems in a way that would help them, that would help IT be able to talk to the business and really cobble things together and remediate things in a way that everyone liked and everyone could understand. From there, I moved into penetration testing specifically. That's where all the fun stuff starts. Those are the guys that break into your company and hopefully give you a really, really lengthy report on what they did to break into your company and what you need to do to fix it, instead of just running in and hacking everything up and giving you the finger and leaving. Who's had penetration tests done at their company? Who's had maybe application testers come in? Yeah, good. Every year I see that hand count goes up, and that's very pleasing because when I first started doing that, it was like one hand in the back, and it was terrifying. And then in my last position, I was an industrial security researcher. That was super fun. The industrial security scene is terrifying. Anyone here working in the ICS space? Probably not. It's very empty. It's like going back into the past. Industrial IT is the average staying time for a piece of hardware in industrial IT is 19 years. Because they're very much into stability over anything else, and so if it works, don't fix it if it ain't broke. That means you're still dealing with 20-year-old software out there in the field, you're dealing with 20-year-old hardware, you're dealing with firmware that hasn't had an update in 20 years. The security implications of that are terrifying. It's a huge problem, and we're not focusing enough on it as a country, I feel like, and that might just be to keep the fear and the raving masses at bay. But yeah, industrial security is a terrifying place to be. I moved out of there because this company, Casada, had developed a really, really freaking cool product for defending web applications from automated attacks. And I'll touch base on that maybe towards the end of the talk if I have time. But I am the director of field engineering for Casada. I'm also a blade runner, meaning I spend a good chunk of my time just hunting bots and doing research on the bots that are out there on the internet attacking all of your stuff. The product we have sucks up all of that general white noise that you get whenever you connect anything to the internet. And because of that, we have a lot of really, really cool data to play with to see what's going on with the internet as a whole. What I'm going to be talking about, here I'll go back for a second. This talk here is for developers, I guess. I tried to bring something that would be for this audience. Normally I'm talking to hackers and hacker conferences. I'm a hacker. I know how to code, I know how to write scripts. I'm not a dev. Everything I do is for speed, and not for stability. I don't do unit testing when I'm hammering out my scripts to get through a situation. Especially as a penetration tester, when I had a very limited time limit to break into things, I had to just write stuff and go. So this is really, speaking here makes me really nervous because you're the ultimate coders. You're the people who do everything right. And I'm the people who do everything wrong. I'm the one who wrote that goofy script you found in a GitHub repo that doesn't even have comments in it and didn't properly use classes and functions, and you're like, what 5-year-old wrote this? That was me. And it was a 5-minute script I needed to hack through and get a job done. One of the reasons we as hackers write a lot of these scriptings is to automate something we're trying to do, because normally if we were doing these attacks by hand, it would take us potentially hundreds of years. I'm talking about trying to brute force a login where I have huge word lists of usernames and passwords and I have to find the right combination. I'm not going to sit there and do that by hand. I'm going to sit there and hammer this out. I'm going to have Python do it. I'm going to have JavaScript do it. I don't have time for this crap. My computer has time for this crap. And so over the years of doing penetration testing and specifically web application testing, I developed this kind of bag of tricks for getting past a lot of the defenses that exist out there that are stopping us from doing these brute forcings, from doing our scraping. Who here, I guess everyone here probably has a need for what they think this talk is about, which is very interesting to me. I didn't realize how big that need was until I started working for Casada and really realized that there is a massive amount of what I've always called corporate espionage going on. And that's I work for one company and I need to figure out what another company is doing, but that company won't just tell me, so I'm going to have to go find out, sometimes based on publicly available information, such as aggregating pricing data for all my competitors, or figuring out what they're selling all of their stuff at so I can make sure that I'm competitive in my pricing. And there's a lot of defenses out there stopping us from doing this. Who operates in a field of that nature? Is that anyone here who doesn't mind raising the guy front and center? Yeah. There's a lot of defenses out there to try and stop this sort of stuff from happening, and a lot of them are really, really bad. And a lot of them are really, really old. And that's why they're really bad. There's two main things out there. There's these basic WAFs, which are, WAF means Web Application Firewall. And the reason it's called a firewall comes from the fact that for the longest time, the majority of them worked based off of IP address-based rules. And the most they could do as a defensive mechanism was blacklist your IP. Some of them later on down the road, and we're talking mid-2000s, they started to be able to do some very basic behavioral analysis. And we're talking about, timing. If something's coming in, if you get X number of requests in X number of seconds, well, that's clearly not a human and we're going to shut that down. That's about the max you can get out of a basic WAF. It's super easy to bypass these simply even just by rotating your IP address. The fact that they blacklist your IP as their only real mechanism for defense is, again, trivia to bypass. I put this up here twice because these don't do much, and there's not much to say about getting around them. It's all right there. Simply rotating your IPs is really all you need to get around these basic WAFs. These basic WAFs are what's out there in most cases as well. These are usually on-prem. These are usually the appliances you have in your data center, and you set them up so your network routes all of your incoming web traffic to the WAF first. It takes a look at what's going on, and then determines whether or not it's going to send those requests over to your origin server or not. In nearly all cases, these aren't in line like that. In nearly all cases, these corporations are putting these in a monitor mode, where they'll alert if something wacky is going on, but they still won't block. The business never lets these block because their false positive rate is so freaking high that it's near impossible to convince the business to allow you to actually block these. Does anyone here work in the security team in their company? Are there any actual dedicated security folks here? One. Yeah, I wasn't expecting there to be much. This is really cool. I love speaking outside of that InfoSec echo chamber and getting this information to people who haven't heard it 1,000 times. But yeah, your security folks would tell you, yeah, the business never lets us block inline. We always just have to alert, and then it floods our inboxes with these alerts, and then we don't care because we have 1 trillion alerts a day, and we're overwhelmed, and here we are. So even tripping the alerts on these things often doesn't get you caught before you've accomplished what you're trying to accomplish, because it takes so long for that security team to come through and actually take a look at what's going on and do something about it. One of my favorite ways of bypassing these WAFs is SQL Map. Oh, by the way, this is a very nutrient-dense talk. I tried to make these slides in a way that are also notes. I have a link at the end that'll show you where to get the slides off of my GitHub, so you can take these back to the office and just have quickie notes to follow along when you're writing your scripts and crap like that. One of my favorite ways of bypassing those old-style WAFs is this tool called SQL Map, and you can take a look at that repo to see the exact mechanisms it uses. The other thing that these basic WAFs are doing is post-data inspection. And they're trying to identify specific types of attacks that come in through that HTTP post data. And they do that by looking for specific groupings of characters or groupings of words. That's all they can do. SQL Map has a really cool obfuscation technique that it uses to still be able to send in injection commands while fooling the thing into not seeing the characters that it's sending through, and it's what you can see what's going on here. It's effectively putting a lot of these null characters in place while still doing union SQL calls. Anyway, if you want to see some cool obfuscation, just check out the SQL Map repo. So between that and just rotating your IPs, getting past these basic WAFs, and the fact that nobody responds to those alerts anyway, getting past those basic WAFs is actually really trivial. And you're going to see that triviality is a common theme in what we're doing here. You're going to be really surprised that most of the things I recommend are going to be simple things that you can add in 1, 2, 3 lines in any of your scripts that you're writing. There's not going to be any devastating, holy crap, this is a really complex attack. I can't believe somebody thought of this kind of stuff in this talk. It's going to be surprisingly basic, and you're going to be really upset at the state of things in the defensive universe right now. So forgive me if I'm also flying through this. There is, like I said, a lot of data in here we have here. There's these more modern WAFs coming out now that I call sophisticated WAFs. These are often exist in the cloud as a kind of a reverse proxy. They operate similar to how a CDN operates in that, like I said, you'll have your DNS send all the traffic up to them first. They'll figure out what requests are good, what requests are bad. They'll send the good requests to your origin, and they'll do something about the bad requests. And that something varies based on whoever sophisticated WAF you happen to be using. These often partially rely on JavaScript execution. This is usually to fingerprint the client environment. So what we're doing here is we're actually taking a look at the connecting client and not just the post data. We're not just looking at HTTP headers. We're not just looking at post data. We're not just looking at IP address information. We're actually seeing what's going on in that client environment. Is this a real browser that's actually trying to connect to my server, or is it somebody pretending to be a real browser? Unfortunately, in most of the cases, that fingerprinting is still not very good. And so what I'm going to do with the majority of this talk is tell you how to get past this more sophisticated stuff, because the first stuff's really easy. Moving on. So let's get to hacking. This is the bare minimum stuff that you're going to do. This next few things I'm going to tell you in this section are the please at least do this. This is the at least you showed up to work today. At least you tried. You're going through the motions. Everything you write should at the very least be doing these few things. Rotate your IP, like I said. You should be rotating your IP all the time. When to rotate your IP is going to vary based on what you're attacking. There's an art to this. You may have to rotate it with every single GET request. If you're bypassing something that's really good at doing behavioral analysis, you might get flagged after a single GET request. And if you're trying to scrape data off a web page, getting stopped after one GET, that's super irritating. But if you can rotate your IP after each GET, that's devastating. That's going to bypass so much stuff out there. And all you're doing is that one thing. And that's something that's super easily scriptable. Obtaining IP addresses for this, really easy. There is no end to free proxy sites out there. Just Google, like it says, just Google free proxies. You can look up VPNs as well, they call themselves sometimes. The paid services, of course, are going to be much more reliable. Whereas the free ones often get blacklisted by IP reputation services relatively quickly. But the paid services are pretty cheap. We're talking $15 a month for thousands of IPs that you can use. There's really cool services out there that will let you lease residential IPs. This is super devastating if you're dealing with the old style WAFs, which, like I said, is most WAFs out there, in that no business is going to allow their security team to block residential ASNs. Like, whose company is going to let you block all of Comcast? You know, especially if you're an e-commerce site. If you're a company where a significant portion of your business comes from access to your website, or you simply run customer portals, if you're, you know, say a health insurance website, anything like that, where you absolutely need individual people with residential IPs to access your website, these will never get blocked. And there's a lot of really cool services that'll rent these to you. Again, relatively cheap, you know, for what we're trying to do here. Where they get these IPs is super sketchy. Because like normally, where do you get a residential IP? You call up Comcast or AT&T, whoever, and you get your one IP address. And if you need a second IP address, what's that cost? What's that cost in New York? Probably $10? $10 an IP, if you can even get another static IP from them. What these companies do is they run these side hustles. Illuminati is my personal favorite. Who knows Hola VPN? HOLA VPN. Maybe you watch it to use it to watch TV in other countries. That's like its most common thing that it pushes. It's a free VPN service. Have you read the terms of service for Hola VPN? No, of course not. Nobody does that. If you skim through there, it's not that long of a terms of service. You'll see that Hola VPN says if you're using their free service, you are agreeing to also allow them to use your home IP address as an exit node for other services. This other company they run is called Illuminati. If you check out Illuminati.com, they lease residential IP addresses. So by using this free software, this Hola VPN, you are an exit node for botnets. You are literally hosting malware from your house, traceable to your IP, mind you. But as people who need some residential IPs, that's a great place to go get them. Monkey Socks is another one. Monkey Socks leases mobile IPs, mobile phone, like cellular network IP addresses. It gets those from an SDK that it offers that anyone who's effectively writing most any mobile app that is capable of establishing a network connection, same thing. It just ties in there and it says, hey, use our SDK, throw our little blurb in your terms of service that you say by using our free app that we wrote for Android, you also agree to let us use your network connections for whatever the hell we see fit. That's terrifying. So that's like any free app that you're using on your phone, take a look at the terms of service. Especially if it's not ad supported, they're getting money from somewhere. This is where they're getting that money from. But you, as the attacker, can go ahead and use an entire ASN full of mobile IPs, which again, nobody's going to block. All right, so that aside from rotating your IP addresses, we're going to start getting into what the more complicated, the more sophisticated WAFs out there are looking for. Again, they can really only rely on the data that you send them for this is like the medium sophistication stuff. Make sure when you're writing these HTTP scripts that you're sending the usual HTTP headers that any browser always sends to them. And you can take a look, just go into Chrome or Firefox or whatever, go to the inspect panel, and just look at the normal request headers that get sent in there. Specifically, I call out the accept // that bypasses so many bot detections. It's hilarious. Because most scripts, most binaries that do HTTP, your curl, your wget, it doesn't send that header. And so these rules that exist on the defensive side just go, hey, does it have that accept anything? If that accept header is missing, it goes, now that's a bot, shut it down. You can bypass that rule just by adding your accept // and you get right in. Sometimes that's the only bot detection going on these like mid-grade WAFs. The do not track is another one that they'll use. as it's more of a weighted thing since it's not always sent in the first place, but you can use that to weight in your favor because they're going to go, all right, we also saw the do not track header, so probably a real browser. Sometimes, depending on the type of communications you're doing and what you're up to, there will be X headers. You guys know what the X headers are, like X forwarded for X. That's like one of the most common ones. These are optional headers where you can pretty much invent any kind of header you want. You just, by spec, you start it with an X and you add whatever data. Look at the X headers that are coming in and being sent when you're doing normal communications on that website and figure out if this is something that you should be adding to your script or not. Watch out for the X forwarded for if you're using free proxies. Because some of those free proxies will add an X forwarded for that will put your source IP, the actual IP you're coming from, in there, and then that just completely blows your cover. Most of the paid proxies don't do that. You want to look for something called like a transparent proxy or an invisible proxy. Most of those are going to not add any header data and will also forward any header data that you add. And so that's really critical for this. Your user agents. Definitely send a valid user agent, something from a modern browser, and you can just go look at what the current Chrome one is, look at the current Firefox one is. When you're copying and pasting your user agents, don't include the quotes. Everyone includes the quotes, and that's the easiest way to detect if somebody's up to something sketchy, because their user agent still has those single quotes in there. And you go, no browser actually sends the single quotes. But they copied it and pasted it right from Chrome, because when you view it in the inspect panel, it's got those single quotes, and they just pasted it, and it's a dead giveaway that this is not somebody using a real browser. So watch the quotes. And then sometimes you want to use session cookies. This is something you're going to have to experiment. And really, this is all stuff you're going to have to experiment with. Try it on, try it off. Generally, the top two are something you're always going to want in there. The other three in the user agent. So X headers, session cookies you want to play with. Session cookies often allow you free access to everything. They often eliminate throttling because you're, especially in an authenticated scenario. So sometimes you're going to go in by hand, authenticate to the website, then grab your session cookie and add that to your script. And the remote server is going to have no rules throttling authenticated people because there's no way they're fake. They're authenticated. Or sometimes they're just even non-authenticated session cookies, but because by default, things like Python requests or curl or wget don't even deal with those cookies. The fact that they aren't there is a great tip-off, and these mid-grade systems will use that to just block you right out of the gate. So again, real simple stuff. We're not hacking anything. All we're doing at this point is just abiding by the HTTP protocol. And that's, again, going to be the overarching theme of what we're doing here. Just make sure that you're mimicking a real browser as much as you possibly can by hand. There's a really cool tool called Postman. I guess I put it later, but here it is. So anyone here used Postman? Oh, great. Oh, good. Fine. Who has seen the code option in Postman in the upper right? It's this big. It's the tiniest thing on the planet. Whenever you send a request out, there's a bunch of links just above the window that has all your data in it, and one of them says code. Click that code link. That code link gives you this drop down that lets you pick the language that you're scripting in, and I just picked Node.js here, and it will generate the request that you just sent in whatever language that you're scripting in. And you can copy and paste this, and it includes all your really cool stuff like, there's your cookies right down there. There's your accept */*. And I pulled this is just right out of a request I dumped in. This is just to go to google.com/maps. So it's going to take a lot of that default stuff that the remote server is expecting, throw it right into script for you so you don't have to spend a ton of time doing this by hand. So definitely check out Postman, even though you guys already are. Rotate your user agents. This gets past so many things. A combination of changing your UA and your IP address is one of the most devastating things you do. Rotating your user agent is often a great way of getting more usage out of a single IP address. A lot of requests may come in from a single IP address for an organization, such as from a university or a workplace. You could have 10,000 people all using the same public IP because they all come out that same exit. Rotating this user agent really gives the look of it actually being an organization with a ton of different users. You can find lists of every user agent in existence anywhere on the internet. There's one, if you look on my GitHub in the scripts I wrote from hacking Venmo last year, I have a flat file in the Venmo script that's it's like 4,000 user agents, and you can just grab that and use it. Again, super simple. You're just taking a flat file with the user agents in it and telling your script, all right, go get the next one, or go get a random one, and just rotate through this. And it looks like it's a bunch of people at some company or some university campus or something on a bunch of different computers, because again, the defenses for this stuff aren't that complex in nearly all cases. You can also do this if you're trying to fuzz a whitelist. A lot of WAFs, and the more sophisticated WAFs, they will have whitelists that people will make the poor decision of just basing off of a user agent. And they'll say, all right, if we see this specific user agent come in, that's fine, just let it through. You can go through and and fuzz every single user agent until you get one that actually lets you in. So definitely make sure when you're writing these scripts and you're trying this stuff out, you're logging what's going on. You're seeing what's working and you're seeing what's not. Because there's a lot more going on in the background than just a binary blanket let this person in, blanket don't let this person in. You're going to be fuzzing cookies. You're going to be fuzzing user agents, things like that. Again, cookies are the same thing. Sometimes you have to provide a session cookie to even get where you're trying to go. Sometimes you can eliminate the session cookie in order to eliminate the throttling. So you can write your script to say, all right, every time it gets a cookie, don't provide that cookie on the next GET request, because the remote server is watching how many times that session has made a request. And they'll do that to try and get around you rotating your IP. Because if you're rotating your IP and you're still providing the same session cookie, you're literally providing the same ID to them over and over and saying, hey, it's the same person still. So make sure you're not doing that. But again, sometimes you actually do have to provide that cookie. So again, it's an art. It's something you're going to want to try both ways. See what works for you. Watch out for sneaky WAF cookies, I wrote down here. The more sophisticated WAFs will often drop identifier cookies that you have to provide. These are the ones that will run a bit of JavaScript on your end, do that fingerprinting, post that telemetry up to their server, and then they'll respond with a cookie that definitely IDs you as you. Sometimes you have to provide that every single time, or it's going to block you outright, or you're going to get caught in this fingerprinting circle and not actually get anywhere. Or sometimes you can get fingerprinted in a real browser. So get that fingerprinting cookie out of the way manually, and then just copy and paste that fingerprinted authorization cookie into your script. This is a cookie replay attack. That's a super common one. So if you're having trouble getting your script to convince the remote server to generate the necessary cookies you need, do it in a real browser, and then just copy and paste that cookie and see what happens. A lot of products are susceptible to that. That's an old hack. It's called cookie replay. It works against a ridiculous number of things. So go ahead and try that. In fact, everything you're doing here, you should be doing manually in a real browser first to understand how the application you're attacking works. And then you're going to write a script to do whatever you need to do. So don't be afraid to copy and paste as much crap as possible. Trying to get through this with the time we have. So again, Postman, we talked about that. I'm going to skip the super boring code demo because you're all developers and I don't need to teach you how to write Python and crap. But that was basically me saying, hey, here's my old Venmo code. Here's where I implemented all these things. I'm sure you guys can figure out how to rotate user agents in whatever script you're writing. Let's talk about the super serious stuff now. This is when we're dealing with the modern, sophisticated WAFs. These are where we're dealing with the really expensive bot defense stuff. The stuff that is able to effectively force you to fingerprint your browser and does a really good job at making sure your browser is in fact a real browser and not just a super snarky Python script that you spent 3 months writing to really mimic a real browser. Occam's razor with this one. Try to bypass that WAF entirely. Try to find another way into the website that you're attacking. I wrote a script, again, it's on my GitHub, and there's a link at the end of this talk to where my GitHub is. I wrote a script called ScanCannon, and it's like a 100-line bash script. And all it does is enumerate the edge of whatever ASN you give it. And it finds all the servers that are running out there. It'll find a bunch of other stuff, but for this purpose, it finds all the web servers that are running. Hopefully, that's going to find some of the edge servers. And then hopefully, those edge servers have crappy firewall rules around them that let you connect directly to them instead of going through this cloud WAF they have set up. This sounds dumb. I see this all the time. And you're literally just bypassing the WAF because normally you'll have this scenario where, all right, you punch in the web address, the domain you're trying to get to, and the DNS says go to this IP address, and that IP address is the cloud WAF. And then you have to try and figure out how to bypass this cloud WAF before it'll let you get to the actual origin server. What we're doing here is just finding the IP address of that origin server and just connecting directly to that IP. So now we're not dealing with, tricking this WAF. We're literally bypassing this WAF. This is really common because people are really bad at writing firewall rules. I don't know why. Firewalls are not complicated, but that's probably it's in the top 3 number of things I exploited as a penetration tester was just this bad firewall rules. So find all the ASNs. Everyone knows what ARIN is, A-R-I-N. This is the American Registry of Internet Numbers. This is the full public list of who owns what IP addresses for American companies. And there's InterNIC takes care of other international ones. But all of these registries are public. And so you can go in and you can say, all right, what IP space does QCon own? And you can get that full ASN, that full list. And then you can go to town and say, all right, let's see what's out there. Let's use running web servers on each of these IP addresses. And this can take you a while, which is why I wrote a script to do it. Sometimes you'll come across the website you're looking for, the web application you're looking for. Sometimes you'll come across a dev instance that has different firewall rules, but in the end still gets you access to the data on the back end that you were looking for. That's really common. And so they'll have prod go through the complicated cloud WAF, but dev doesn't have to because it's just dev. But they screwed up on the back end and let dev still access whatever you're trying to get. Or the dev site will use live data. We as devs know that this is a stupid idea. It happens all the time. Who's seen this in a company they've worked for, where dev had prod data in it? It's common. Don't be afraid to go look for it. You can save yourself a lot of time. You can, if you're forced to go through this cloud WAF, a lot of times they're using a CDN in front of it. And CDNs have path rules that will pass certain requests for certain paths through the WAF, and other requests will bypass it. Start fuzzing the paths. That can be hard. You're literally just punching random words into the URL path. But see if you can find a URL path that gets you to the place you're trying to get to and doesn't force you to go through that WAF. This is some more advanced stuff. This is a lot of last resort things, but that's where we're at this point in the game. And a lot of times you'll find that accessing an application via a different URL path or a different means has different rules associated with it because somebody forgot to add them into the CDN. So CDN has 6,000 rules as it is, and nobody knows how it works, and now you've found a way in that they weren't aware of. Start smashing their DNS. Find other domains that company owns. You can do that by, you guys know what DNS zone transfers are? Write that down, Google that. That allows you to dump every domain name that's registered within their DNS server. Look through those domain names. Does anything have the word origin in it? Here's a real common one. Look up if a company has www-origin.companydomain.com or whatever the TLD is. That's a freebie. There's someone very popular out there using that as a way of hiding the origin servers. And there you go. So look for the word origin or something that looks like an origin server just within all the DNS names that their DNS server has. And just start hitting that. You might work. You'd be surprised. I told you this wasn't going to be any like devastating, insane, complicated hacks. This is simple stuff. You just have to think outside the box and find other ways in. If you're able to get in, but you're being throttled, and you can't figure out how to defeat this throttling that's happening to you, find all the edge nodes, find all the IPs that are hosting whatever it is you're attacking, and attack only one. I used the term round robin here incorrectly, I think. Attack only one until it stops you, then try attacking the next one. There's certain WAFs out there that have a really long window where the blocked IP info gets synced up. Some of them as long as 15 minutes. And so you can attack one, and then you've got 15 minutes before that one tells all the other ones to start blocking you. So then you can just wreck the next one, and then wreck the next one, and then rotate your IP and start all over again. This is so much to go through, and I know I'm kind of running a bit lower on the time. We talked about the path rules. Look for an API that hosts the data that you're looking for. Oftentimes, this is just domain name / API. Go look. Just type that in your browser and see if it exists. APIs are almost always less protected than the actual websites themselves. And that's often because of the systems that need to interact with the API not being able to interact with it in the same way that a browser provides. You're not able to fingerprint the connecting system because maybe it's a mobile application. So you can't protect the API in the same manner. Look for that API, because that API may be providing the pricing data you're looking for. It may be providing whatever you're trying to aggregate, that API may allow you to authenticate. You could possibly, if you're trying to brute force some login credentials, you could brute force against that API, and it will have completely different rules associated with it. Don't assume that everything on their website has the same rules. Don't assume that every URL path has the same rules associated with it. Every single page and every single means of getting to that page can have its own rule applied. So don't assume anything. Always try everything. We talked about look for, oh, this is a good one. Let me go back here. Look for UUIDs are like really complicated DNS names. Again, when we're dumping that DNS, look for something that's like super long, and you go, what is this? Especially in a scenario where it stands out, where you go, hey, these three servers, like these three names are really long hashes, and then everything else is very obviously named. Those are probably obfuscated origin servers. They're definitely obfuscated, and they're obfuscated for some reason. See what they are. Check those IPs. Use a tool like Nmap to see what ports are hosting services, and that'll help you figure out what that server is. Just connect to it on 80 and 443. It might be what you're looking for. There's a good chance that's an origin server, and that might be what your target is for this particular situation. We talked about the WAF cookies. Look for these more complicated WAFs, like I said, they're going to throw down JavaScript snippets at you. Sometimes these snippets are inline in the page template itself, and every page has the same one. Sometimes you'll send a GET request, and your response will be just a blank page with a JavaScript fingerprinting snippet in it. And then you have to process that JavaScript, send back whatever response it's looking for, and then you'll get a valid fingerprinting cookie that lets you continue. Take a look, see if those are happening. Sometimes it's as simple as just not running that JavaScript. Block that specific snippet, and it'll fail open. There's definitely a pair of products that just simply fail open if you don't run their JavaScript. That seems ridiculous to me. That's a thing that happens. Or, like I said, run that JavaScript. Run it in a regular browser, take the resulting cookie, dump it in your script. Cookie replay. Say, thanks for the cookie, I'm going to put this here now. Everything works fine a lot of the time. Failing all of that, this is where it gets devastating. Just automate an actual real browser. Like I've been saying, what you should always be doing when you're trying to do anything that interacts with a website is you go interact with the website yourself manually. You see how everything works. you make some notes, and then you write a script that's going to accurately kind of recreate what you're trying to do to make this website work for the computer. Why don't you automate that? That's where things get really fun. That's what bypasses so much stuff. It is, however, a bit more complex, and there's a bit of a learning curve to it. Who's heard of ZombieJas? PhantomJS. PhantomJS is a real popular one. Yeah. So those are kind of deprecated more or less. Neither of those are being maintained by the original creators anymore. I think Phantom is still at least community maintained. I believe Zombie is totally dead. Anyone heard of Arachni? It's a web application vulnerability scanner. Yeah, that one just operates, I believe, yeah, it runs PhantomJS in the background, and it uses that to to increase its ability to access more pages within the browser by actively running the JavaScript. Those used to be the way to go for a long time because they were tools that would run JavaScript and pretend to be browsers by the mere fact of, hey, I run JavaScript, therefore I must be a browser. When we're dealing with these modern WAFs now, they're actually doing a lot more hardcore fingerprinting than just, hey, can you run JavaScript or not? Well, some of them are. There are still a ton that are just seeing if you can run JavaScript or not, and that's a terrible way of fingerprinting anything to determine if it's a real human in a real browser. These days, the things you want to be using are like Selenium. You guys know what Selenium is? Selenium's super popular in QA testing. And Puppeteer. Puppeteer and Headless Chrome, anyone using that? That's my all-time favorite. Absolutely love Puppeteer, Headless Chrome. I'm not going to get into a super lengthy how-to on how to use Puppeteer here. It's got a learning curve to it, but honestly, you can watch an hour-long YouTube video that you can Google up and get the gist of how it operates. The deal is that Selenium, Puppeteer, they're running Headless Chrome. Headless Chrome is Chrome, more or less. Headless Chrome claims that it's a clone of Chrome, and it does all the same things that Chrome does, and it looks like Chrome. It's not exactly true. There's a lot of things going on under the hood of Headless Chrome that kind of give it away. And if you're dealing with something super complex that's really digging deep into that browser, it's going to identify this stock Puppeteer Selenium Headless Chrome setup right out of the gate. But it's kind of rare you're going to come up against that. So definitely even just try the stock config and see where you get. Automating it is super easy. It's mostly JavaScript. It's very similar to JavaScript. And that's going to get you a really long length of the way. It looks like human activity because you're using a real browser. You're using Chrome. And you can set your timing in there. You can set your throttling just like any other method of scripting. It executes JavaScript to the fullest extent. It executes JavaScript because it uses the same JavaScript engine that Chrome uses. Except, well, I won't get into that. Don't worry about it. It properly leverages cookies. It does that whole trade-off the way it should. It stores cookies. It does sessions properly. You can run multiple instances of it per IP because it's just a browser. And just like you can open multiple browsers on your computer, you can do that there. If you're going to be doing this, and I put the link to it up there if you guys hadn't seen that before. If you're going to be doing this, go into your WebDriver settings for Selenium or for Headless Chrome or for Puppeteer. Change at the least these aspects of it to make them look more realistic. Depending on what you're using, sometimes these will be inherently discerned by the WebDriver. Again, the WebDriver is this automation tool. It's literally like someone driving your web browser. And say if you're running this on your AWS instance that has 12 cores in it, your WebDriver is going to report that you're running a 12-core CPU. The average user of a website probably isn't running 12 cores on their desktop computer. So you want to fix that. These are the things that a lot of those complex WAFs out there look for, even in the automated browsers like these. If you change these things to be more reasonable for what an average user would have, like screen resolution. A lot of these default to 320 by 240 for the screen resolution. Some of them default to 1024 by 768. Nobody's running that these days. That's an insanely tiny screen resolution. Change that. Go through these, once you see them, they're obvious what they are. Set these to normal, what I call normal human values. Set these to like what your mom would use. And that's going to bypass a ton of the most sophisticated WAFs that are out there today. And so that's all I got time for today. Oh, here's a summary if you guys want to take a picture of that. Go ahead, take pictures. The next slide's going to have my GitHub repo, which has this slide deck in it. So you guys can also download it and just take it to work and use it as like notes. I'll give you a second. That's all I got time for today. I told you this was like super nutrient dense, and there's a lot to get through, and all I had time to do was like say, hey, do this thing, and then you're gonna have to go do a lot of Googling to see how to do the thing. But now that you at least have that thing to do in your bag of tricks, you're gonna get past a lot, like 90% of the things that have been stopping you up to date. So again, I'm Johnny Christmas. There's the GitHub repo on the bottom. You guys take a picture of that. I'm super active on Twitter if you want to ping me and ask any questions. There's my company, Casada. We at Casada do sell a product that is not susceptible to literally anything I've discussed in this talk, because that'd be weird if it was. Yeah, so if you're at a company who's trying to get around people who are launching these more sophisticated attacks at you, go ahead and give me a call. We can talk about that as well. Yeah, hit me up directly, and I'll talk with you, and then you don't have to deal with weird sales guys. So thanks a lot. Have a great QCon.